Welcome everyone to the next webinar in the series of technical webinars of Agiliway, and I guess that's already about third or fourth webinar related with Clojure stack from the company. Welcome the new level of team agility with Clojure stack, and basically the key speaker today is Andriy. So we'll do some short intros in a second. Hi, everyone.
Yeah, hi, everyone. I'm also happy to greet everybody here today, and I hope you will enjoy our webinar.
Cool. Let's then start and move to agenda first. So we'll start with discussing the bus factor problematics, which is basically somewhat of a usual thing in the delivery of the various projects, particularly software projects, and basically later we'll come to figuring out the solution to this problematics. We'll talk about the importance of interchangeability, and that will basically, as you guess, be a part of coming into the solution making. We'll discuss about the new possibilities with Clojure stack, Clojure and Java, interoperability, ClojureScript and JavaScript, interoperability, and the project benefits, as well as the newbies challenges in this stack and solutioning with the stack. And you'll probably, I hope you'll have a few minutes for Q&A, but please do not forget the chat or the Q&A window to drop the questions as we go, so that we might even respond on the go or in the end when we have these few minutes left. Cool. Then let's move to short introductions for those who haven't yet attended the previous webinars. I'll probably start with me. It's Viktoriia, but you see Vika. It's a short version in the Zoom. I am the delivery director at Agiliway, and happy to participate in a number of projects that are delivered in Clojure stack. And basically, Andriy, over to you.
Yeah, I'm Andriy, and I'm a team lead in Agiliway. But in general, I have like around 8 years experience in the industry and more than 3 years with the Clojure stack. So I hope like we can have some kind of interesting solutions here for you today.
Cool. So what we are going to basically kick off from here today is to understand what our goal is very often in delivering software products. So the goal is an agile team. Very often, of course, we can speak a lot, and we will not, about all the other versions of moving forward, because basically that's already for a very long time mainstream in delivery of software products. But it's a very high level and very kind of at the same time precise definition, but it also gives the field of discussions how to basically achieve being agile, moving agile, and creating high-performing agile teams. So what is an agile team? In our definition, basically, it's not only our definition, of course, it's a common definition. It's the team which is reliable, flexible, it's coordinated in being flexible, it's independent, but being flexible is obviously, and coordinated, it's obviously co-creates, sub-creates with the general vision of the product. It's mature enough to do all the above, and it's definitely passionate to achieve all the items above, and basically the teammates complement each other in order to achieve these reliability, flexibility, and so on and so forth. And I'm sure that most of you, if not all of you, came across the problematics of keeping this team basically productive and effective enough, and at the same time keep it motivated, passionate, and we obviously all as human beings and as individuals go through different processes in our life. So obviously we unfortunately get sick. We have different kind of personal situations in life, and of course, we have vacations and other kind of things, probably not that positive and nice and shiny, but we are also concentrated on kind of balancing all these things with delivering successfully the products and making sure that we do not fail our customers and our roadmap and our goals and so on and so forth. And there is such a term that you basically, I'm sure, came across as the buzz factor. That's what we are going to come across while explaining one of the main challenges in keeping the team agile and flexible and high performing. Basically, we I guess we understand the definition of buzz factor, but just so I understand, you understand, and we are on the same page, could you please drop some ideas into the chat window? How do you see the definition of the buzz factor, so that we are on the same page and we can move on? Yeah, you have the possibility to, I hope you have the possibility to write in the chat window. So if you could, please. And it would be really helpful if you wrote something so that we understood you can hear us. At least write, I don't know, test or something, please. Okay, I can see the Q&A. Cool. Yeah, as any of the windows are doing fine. So you can basically use the Q&A window if chat window is not working quite well at the moment. So I would really love to understand like whether you came across the buzz factor in your teams, how we will come next to the how do you deal with the buzz factor on your projects, companies, etc. But to start from, how do you understand the buzz factor? What's that? Don't be shy. Well, it's not, it's not an exam. It's basically us, Andriy and I talking. So we'll continue talking. But okay, thank you, Zari. One person hard to replace. Yeah, when there is, basically you gave the shortest and perfect definition. When there is basically no way, yeah, it's some unexpected issue, right? You are, Carrie. When there is no possibility kind of to replace somebody, or basically it's not just a person issue, it can be something else. It's an unexpected issue that just like crashes us basically, and we cannot withstand it. Cool, thank you. So basically we are on the same page here, and I'm sure that well, we all try from all perspectives, not only like management or leadership or engineering. We all try to kind of live with the buzz factors in our working atmosphere, and to somehow deal with them, to somehow predict how we can deal with them. So I wonder if you could please answer this short questionnaire, and we'd like to know, Andriy and I, and basically everyone here, how do you usually deal with the buzz factors in your working conditions? And there are 4 options. Especially the buzz factor here we are more concerned with is the person or person's absence. So all the options here would be mostly related with the person's absence or whatever, sickness and so on. And if you have other options, please write in the chat or Q&A chat. We would really love to know how you deal with the bus factor.
And I would like to add that this is also kind of just a bottleneck problematic, you can call it that way. So even it can be just a knowledge holder in general that is unable to provide a service for some reason.
Cool, so we are waiting for your voting, responding kind of on this poll, and we'll see the results. Andriy and I cannot vote, so we'll be dependent on our host, who would help us to know when the vote can be finished so that we can see the responses. All right, so we have some responses, and basically we have main two big groups of responses: time or scope changes with the client and optimizing the processes. There is also like the change into full stack on the project, and I don't know if there are something else on in the chat.
No, seems no.
No. Okay, cool. So basically, these are like two main groups of dealing with the bus factor on your projects, on your product, and we will be sharing lots of stuff we are doing to deal with the bus factor. And usually, very often, it will not probably be something new for you. The bus factor is related with some issues with communication or clarity on the project. So writing documentation is definitely one of the things how we deal with the bus factor on many projects. Of course, we have the code review. We try to stick to code review and make it like make sure that we are serious about code review and it's not just like a check mark activity on the project. We definitely try to stick to pair programming so that we communicate better and we understand where the gaps in communication are or what should be kind of documented for the next generations, etc. And another thing, of course, we have here daily stand-ups, I'd say daily meetings, but like meetings is a sensitive topic, so I will not stop on it for a long time because for many people it's like, you know, a red signal. We try to kind of stay on the same page with the meetings and not overload with them. But one more thing that is basically very important for us, and we will definitely concentrate more on it before we go into details with Clojure Stack, is interchangeability. Make your team interchangeable is like a motto here, and we'll be talking about it throughout the webinar. We think it's really valuable and it's really important to be able to basically have to be able to have the interchangeable team as much as possible, and in this way to make the communication better, to bring this clarity that probably is not brought enough by the documentation or the meetings, to make sure that everyone on the same page by being on the same code page, and we'll go into kind of many details about that. And basically, we will be talking about being kind of welcoming into our joint effort, into joint project effort by sharing. And it's very important for us to be able to share not just like orally by the word of mouth, but also be able to share by sharing coding responsibility. And we will be making sure that by making this interchangeability, there'll be no need to kind of bench people to be able to kind of rely on the huge number of people to perform different duties, and so on and so forth. So how do we not bench people? Basically, there are different ways to stay away from benching people and to kind of rely on a very large team that has very granular duties, and everyone should kind of learn lots of high-level information about the business by performing very, granular duties. And so we thought, and of course we tried the option hire more staff on the projects, but healthy bench is around having around 5 to 8% of the let's say employees on it. And also the extra the bench is basically the extra costs that are not always healthy to the project kind of effectiveness for the company, or the product effectiveness for the company. There is always a need to have a stable load in order to manage the healthy bench that would help in the bus factor situations. And obviously, it brings higher risks in the situations that are basically extra product or extra project that would happen to, I don't know, the certain group of people or company that operates in certain environment. So basically, most of you responded in the same way as we are going to lead you, and communication and interchangeability would be the main focuses of overcome hiring more staff, benching people, and just sitting there and piling for the risks. So the solution that we came to use as one of the most effective and less costly would be involving people and basically investing in full stack. So here I'll pause for a second for this lovely picture of a full stack engineer before getting it over to Andriy.
Yeah, thank you. So basically, the idea of getting the full stack development is based on simple thought that you can get a developer that can handle the most of the tasks you have. Sounds simple. So, but that actually, in one way, it solves a lot of problems. So one person know a lot of different technologies, have enough expertise to work on a different scope of tasks, and are capable to provide some valuable result and realistic estimates on a different ends of your project. So that sounds very good and really cool for any project actually, but also that sounds expensive. So it's not very likely to be a real truth in a real life to find that one developer or a group of developers that should know a lot of different technologies that can be really different. So let's imagine some general stack, some JavaScript on the front end side, if it's a web application, and some Golang or I don't know, Java or Python, whatever. It's two different languages, at least, that your developer have to know, two different domains. So it's hard to find that kind of person, and it's costly, first of all, to even in terms of resources and time, to have the person that is exactly match your requirements. And also, in a bigger team, it's always is about a focus. So even if you find a full stack developer, he will have some certain focus based on his background, and he anyway, he will know some part better, and he will try to focus there. And at least from our experience, there is always a wish from people to get closer into that part of project they like more or they know better. And what are the other options? So full stack is a great option. It's not a perfect, it has some limitations, let's say like that. But what else can we do? In our poll, like there was an option about changing your processes, improving just general management stuff. So that's also possible. And that's the great way to proceed. But we all know how hard it is. So it's just great and easy to say, but on a real world and real project, it's very hard to achieve, to change your entire flows, to change the mindset of people. Just it requires a serious effort to do that. We can also like have some other option is like try to reduce the amount of technologies that your full stack developers should know. And one of the most important example of this, one of the most popular example of this, sorry, is JavaScript and Node.js combination. So it's basically the JavaScript on the both ends. So if it's a web application, again, you can easily like, it's almost like the same language, just running on different environments, but it has some limitations. So it's still a JavaScript, so it's kind of a simple threaded. There can be like some workarounds for this, but they're not like that fancy and easy to work with. It's also like the event based, so in general, there is just some limitation how you can use that technology stack. And for example, it's also not that good for some serious computations, math and stuff. So like usual, there are pros and cons for everything. But that's just one of the most like notable examples that we have in the industry. But we have another great alternative to this, and it's the Clojure stack. At first point, it's something similar. So that's the Clojure language and the ClojureScript language. Clojure serves for a backend part, and the ClojureScript is more like to serve the UI purposes and stuff like so. Imagine like the JavaScript is the ClojureScript and Node.js in this case is the Clojure. But what makes Clojure that different from, I believe, any other options that we have is its origins and its structure and the possibilities and the flexibility it actually gives to us. So let's try like to start from the scratch and figure out what is actually the Clojure and what it gives to us. So first of all, it's the functional programming language that is a dialect of Lisp. So it takes its origins really back in history. I believe Lisp were created in 1958. That's very long if we are talking for IT industry. But the Clojure itself were done in 2007, so it's a relatively modern technology, but it's a dialect of Lisp. So it just took the basis, it took the best things, and it made it work like, in the best way I think it could. It's really neat and simple, but at the same time, it's really powerful. So the Clojure syntax is really small. So there are not a lot of characters in it, not a lot of constructions. You have few data structure types. You have just some parentheses. You have a possibility to define a function and variable. And that's in general, that's it. There are no some specific structures that is making this syntax hard to learn or to master. What make Clojure different is the immutability. Clojure is completely immutable, except one small note that I mentioned a bit later, but all variables in Clojure are immutable. So once it's created, you cannot change it. It actually makes the code very like, oh, bug safe, I would say. So it's really hard to make bugs in this kind of structure, because when you wrote something, you run it once with some set of data, and you can be 100% sure that it will remain same no matter what. So in object-oriented programming, we usually have a lot of classes, a lot of different structures, relations. So there can be a case that some value were modified by a completely different function, and you did not expect that. You're trying to debug that, putting a lot of breakpoints and trying to figure out what's going on. In Clojure, it's not a case. Like, it's something closer to a test-driven development, when you can simply write a function that, if it takes some amount of arguments, it always will return the same value. And it's multi-threaded, so pretty important thing for some serious computations. So it creates us more possibilities. And what others think is really cool about it is that Clojure treats code as a data and data as a code. That has a term, it's homoionic, and it's inherited from Lisp. What it means is the code written in this language is encoded into data structure that language has a tool to manipulate. So Clojure can manipulate its own code. You can actually write a code that can write a code and then evaluate it. That sounds a bit weird at first point, maybe, but like, it gives you a lot of possibility to modify the Clojure itself, to modify what you're writing, to change your way of what you are doing. And the other very great feature of Clojure is that it actually compiles to JVM bytecode. So at the end, you have actually the same output as you will have from any Java code. So you can also run it same as we have with Java on every platform, because Java is platform independent. You can just install the JVM, Java virtual machine, and execute it. It can be any environment. So that creates this flexibility for Clojure as well. And also Clojure has a lot of parentheses. You can see it on the right. So it's an example of Clojure code written by me, by the way. And there are a lot of parentheses. We love parentheses in Clojure. There are a lot of them. And like, there are no way to deal with them, but like, we're used to it. And back to Java a bit. So what this combination with Java bytecode gives us is a possibility to interop with Clojure. So like we can mention in an agenda, Interop stands for interoperability, and it's an ability for two or more languages to interact in the same system. So what it means to us, that you can actually import any Java code into a Clojure, and you can use it in Clojure without actually knowing Java. You just can like include some library and use some function from that library. You don't really care what is inside. You don't care like how it's exactly written. You don't need to know like the Java in depth, maybe some just a general idea. So that it's object-oriented and there are classes, but it doesn't stand against the Clojure immutability and functionality. So this is very important, and I want everybody to pay attention to it, that you can really use any existing Java code, any library in Clojure. You can simply import it and use it, like on this example. So it's the simple like data formatting, the current date, and it's taken from Java, because like, why do we need to use something else if we have a fancy solution in Java? Very simple. So the syntax at first look may look a bit weird, but like, believe me, you will use to it in a week or two when you start using Clojure. So that's only first impression. In general, the Clojure code, I think it's one of the most like well-structured code I saw in the different languages. So I tried some, so I think like it's a valid option for you at least to think about. And the other side of this is a ClojureScript. So it's still a Clojure, yeah. So ClojureScript in general, it's the same thing as a Clojure in terms of syntax, in terms of structure, basically everything, but it relies on a JavaScript, not on a Java. So once more, we have a Clojure that can compile to Java, and we have a ClojureScript that can compile to JavaScript. But Clojure is in between, and it actually is the same code, same project, if you like, but that can be compiled either into Java or into JavaScript. For JavaScript, we use ClojureScript, and it goes like that just because, like, obviously, when you are working with JavaScript, there are some small amount of differences, but I would say there's around 80 or 90% in common between Clojure and ClojureScript. But what makes ClojureScript that great is ClojureScript out of the box uses the Google Clojure library. It's Clojure, a bit different, so it's not the same thing. It's not created specifically for Clojure, but it's the optimization library. So it allows us to like avoid this pain about compatibility with different browsers or stuff like that. So it eliminates the dead codes, doing a lot of useful stuff, optimize the code and stuff like that. So we can rely on what Google did, and Clojure use it out of the box. So you don't even need to worry about it. But the great thing is that you can actually use any Java library in this case. JavaScript library in this case. So, for example, we have a reagent. That's the ClojureScript library that is created specifically to work with React. You can use React directly in ClojureScript, but it's not so comfortable, easy to handle that complicated library. But we have a reagent. It's our own library in Clojure that serve that issue. It's just for our comfort to make it more Clojure-like. And it actually allows us to write React applications on ClojureScript. We also have like a kind of a own template hiccup style engine that allows us to write the HTML structure. So it just basically the same in this example React project that has the React components, has all the React features. We have our own Redux in this case, but we can use the Redux like originally as well. So that's not a limitation here. But what I want to like say that this is the same possibility that we have at Java. Just use any library you like with the same syntax, and this will be compiled to JavaScript in this case. And last point, that it supports a hot reload. So that's not something unique, but really fancy. That just allows you to write your code like simultaneously. When you make some change, it's automatically appear on the screen. So here I will share just some animation of live coding, let's say like that. So you can see that the general, it's a ClojureScript structure. And what I mentioned is a hiccup structure. So you have the div, you have h1 and p, so that's regular HTML. Here, it's generated purely in Clojure objects. So it's not, there are no difference from any regular code that we wrote in Clojure. It just treats it as HTML, this Clojure data structure. And you can create a simple React component just like with a small amount of code like that. You can control the state. So it's it's really simple, and you always have the result like automatically updated on your browser, like without having to refresh it. And it's like really fancy way to handle the front-end experience. It also, like I mentioned, support the complete interop with JavaScript, so you can even write the native JavaScript if you like. It's not that, like, I'd say, doesn't look that beautiful, but still, like you have a possibility to do that if needed. So it's just like here you see an example of creating the same button I did on a previous screen, but just with a pure JavaScript. So, but at the end, both code will be compiled into the same end code and will be executed on your browser. There will be no difference between those two pieces of code. So it gives you that flexibility, and actually you can have the same language that serves a lot of different purposes. If you need a desktop application, here you go. You can use Clojure. You can use a lot of Java libraries that already exist, and you can have this desktop application written in Clojure. If you want to have a mobile app, you can use ClojureScript, which is almost the same. You don't need to learn a new language. You don't need to like know new rules, how to work with that. It's still a functional programming. It's still a Clojure, still the same like concept, but you can use React Native to work with the mobile app. Easy. If it's a desktop application, if it's a web application, you can build your front end on ClojureScript, backend or API, I mean, on Clojure, and it's the same thing. So the same person can actually learn one technology and serve a lot of different purposes with just a little of extra information for that extra technology you need. I mean, like for Java or JavaScript, you don't need to be an expert there. You just have to know Clojure, and you have to know how to work with that and inject some extra libraries. But that's not the end. We have other great features that is a REPL readable print loop. What it gives to us is the ability to actually evaluate any piece of code at any moment of time. And it's not Clojure unique feature. You have it in other environments as well, in other languages, but I never thought anything that gives you like this kind of a flexibility and possibilities out of the box. And that's because of Lisp origins of Clojure. So let me switch to the next screen where you see just what exactly were happening on that animation. So you have some small function that just square two numbers, and you can run every piece of code like just as an independent structure, and you can immediately evaluate it to get the result. And it doesn't really matter where exactly you put that evaluation. So you just put the cursor at some parentheses, press a button, and you have the result. So like you just need to initialize your function to load it into this REPL environment, and that's it. So like in the first step, we imported this square function into our REPL, then executed this square6 function, we get our result, and then something more complex that just stands for applying this square function to each of the numbers from 0 to 9, which stands behind this range 10 function. And if you like, you can just put your cursor after this range 10 parentheses, and you will get the evaluation only of that form that is in those brackets. So you can simply test any chunk of code you like at any time. You can, like I said, it's immutable, so you can rely that if you make some function and test it with some value, get some result in any other moment of time, it will return you the same value with that input data. So you can easily make this testing. I rarely need some kind of breakpoints here. So you can always be sure what you wrote, and you can always test what you wrote like immediately. And that's the very great feature that really reduced the number of bugs we made in our projects on Clojure Stack. And I think that's the significant improvement in general for any project. Because if there is some bugs, like there's no way to like get rid of them, it's something bigger. It's something like in the logic or stuff like the general functionality of our project. But each function itself, if it's well tested, it never will provide you unexpected result. And the other great stuff we have here that actually the same libraries can be used with Clojure and ClojureScript. That's a possibility that given to us like because of this interruption. And so we can have a same function that depend on the compiler. So if it's this function, if it's compiled by a Java compiler, it will use the Java interruption and the Java code. So like we see here on the example that if it's CLJ, it stands for Clojure. So it will use the Java to convert string to int. And if it's the ClojureScript, so if we are running in a different environment in a browser, we can use the JavaScript for it. And it's just a different function. Everything else that we have in this library will be the same code. It will be the same logic. Like it creates us an ultimate possibility just to create a huge reusable code base that can serve different platforms even. So you don't need to care where it's executed if you handle this kind of situation. Of course, you have to like be careful because like, for example, Java is multi-threaded, JavaScript is not. And there are stuff like that that you have to be aware. Like I said, there is 80 or 90% of similarity, not the exact things. But that's something we can handle. That's something we can move out from our libraries. But in general, you're able to create this sample that serves you a great purpose in real projects. And here I'll pass to Vika.
Thank you. We have a couple of questions in Q&A section, and while I'll sum up where we were at before going to the real life example, I will also try to answer with Andriy's help these questions. They're great questions, by the way. Thank you for answering for asking them. Basically, to sum up what Andriy and I were discussing about the way we solve the enhancement of agility on our projects and reducing the bus factor is using the set of Clojure and ClojureScript full stack engineers on our teams, on our squads, teams, projects, etc. Andriy, if you can help me with the slide, please. We do basically try. We do try using same stack for every purpose, as Andriy mentioned, with this great Clojure possibility to basically just use a shared set of libraries, and it all depends whether you use it with Java or JavaScript and which platform you use for, but you don't have to kind of reinvent the vehicle every time. So same stack for every purpose, and shareable libraries would be these three key items that we have here underlined. Apart from that, I want to, by saying that, I'll try to answer two of the questions in the Q&A section. It's very cool that by the very nature of the language and by the very nature of ClojureScript combination, it's kind of a natural process that makes the engineers who use the stack to think end to end. And in many cases, it's kind of a hard work for either product owners or project managers or business owners, or a combination of these all I mentioned, to work with their engineers to kind of share the vision of the product, to make them think end to end, to reduce this thing, you know, like, oh, I am a backend engineer, I don't care about front end. Oh, I am a front end engineer, that backend that doesn't work, and so on and so forth. With Clojure, what is so cool and what boosts the like quality, speed, communication, clarity, etc., is that you have to think end to end. You cannot not think end to end, because you can if you don't really want to, or usually very often, let's say, Clojure engineers, they are not kind of freshly born Clojure engineers. They usually have other stacks in their experience before converting into Clojure religion, so to say. So usually in the past, they specialized either in backend or frontend, or even both, but like doing, as Andriy mentioned in the previous slides, let's say some purely backend language and some purely front-end language, in kind of best case JavaScript, Node.js, or something of that kind. But basically, there was always some kind of specialization. With Clojure, you have this mindset shift into end-to-end thinking, which I think is like basically a very cool thing that creates this agility per se. And answering one of the questions in the chat, I think it was Anthony's question. Basically, you kind of spare spare the overhead. In fact, you sometimes you have less overhead with Clojure engineers, because a smaller team of full stack interchangeable engineers can deliver more and faster. And that is why my personal experience is that Clojure is so cool for startups. It's so cool for dynamic environments. It's so cool in the situations where you have even rapidly changing requirements and rapidly like very dynamic communication with the business, with the product, and so on, because that's okay. Like, you don't have to have a lot of latency or cross communications between the front end and back end engineers on your team, because that's one person. That's one person that is working on a feature, and that's a great value as for me. And also, you don't have to have this great, like, huge team of front end and back end engineers. Well, you can have the shared understanding and basically people who are working on features, not on front end or back end. Answering, Carrie, your question, basically, I just want to confirm that yes, we do have knowledge transfers and pair programming, obviously, like quite often, and we will talk in a bit more about that in more details. Coming to the same point, that the end-to-end thinking of the engineers who do Clojure is natural, like it's coming from the language. It's a very cool thing that helps kind of the Clojure engineers to not just to be the recipients of the documentation, but also to co-create this documentation, because they have this product vision and end-to-end thinking. We do not kind of I wouldn't mix this item with the general topic of our webinar today, but basically we tried to document key processes, of course, and basically with Clojure, it makes it quite easier in many ways to keep track of the processes. Let me see if I didn't skip anything. Yeah, and to the note that Carrie made about avoiding one and only rock star in the team, I can't say, you know, it's a psychology thing, but in Clojure, where you have everyone working on I mean, not everything, but like front end and back end being full stack, there is obviously it's a psychology thing as well. It's an individuality thing, but usually just because the language specifics and history and the market, of course, as well. Usually Clojure engineers are the engineers, as I mentioned before, that have this past experience in their life in other stacks. So usually the Clojure engineers are already quite more senior than other engineers that just come into the craft and or you know, the art, and they basically speak a little bit more high level language and have deep understanding, which is and actually Clojure engineers are very close-knit community. We will speak about that later. Andriy definitely will mention that. So that leads to a good teamwork, I would say, as well as one-man work if needed. Cool. So let's move on to, I wanted to exemplify how we used Clojure stack for our like real life example. Was one of our customers. We were building a communication platform. So there was a task to build a communication platform, which would be obviously the front end, the back end, and a number of integrations. We were actually working on multi-means messaging for vast recipient groups, which means high load, which means thinking about performance and spikes and many other issues, which will bring the topic of JVM and Clojure as the stack that can be actually used for high loaded systems. We were supposed to build quick and easy UI wizard for setting up the communication campaigns. We were supposed to be delivering the dynamic front-end templates that would enable the easy setup for our target customer group. And the system, all the modules of the system were supposed to be highly secured and compliant with various standards of PII, PHI data transferring, because the system was built for communicating with various, let's say, recipients of healthcare related or fintech related information. So there was a big focus on building a secure platform. The platform was built in Clojure stack, and basically, if I might be mistaken, so Andriy, please help me, but the team that built this platform, and the platform was built roughly in about 4 months, and from the 0 point to the point when it was released. And the team that built the platform consisted, again, I might be mistaken, so Andriy, please help me, but like the number of engineers working on all this system was 4. So coming back to the question that Anthony, you asked in the Q&A section, you can actually build quite a substantial platform with both like end-to-end features and high loaded system with 4 engineers. And Andriy, you are nodding, but maybe you wanted to add something.
Yeah, I wanted to add that probably there were even like 3 engineers that were working all the time, and 1 that were switching between other projects. So that's another important option you have. It's easy to like pull your developer from one small project and insert it into another, because that's the same stack no matter where he's working. And there is still a good level of understanding on that original project he was pulled off, because every person in a team understand every aspect of the project, and it's really easy for them to understand that because they can read the code. It's the same code they usually see, nothing really different there, and they can understand each aspect of it. They can make some adjustments or fix if they like. They don't need to ask another developer, hey, I don't understand like what exactly you did here, like because it's another language or another tool. It's the same common thing for all of them, and like it's reduced even this communication sometimes.
And of course, you don't need to say like, oh, I need a front-end engineer here, or I need a mobile engineer here, or I need a back-end engineer, because they are all that. Then let's just do it. Yeah. Exactly. And so the project benefits that we wanted to summarize are basically proper handling of bottlenecks, the reusable code base that, as Andriy mentioned, you can jump between the different platforms and projects and it's still there. The quite faster delivering based on what we discussed, and stay agile and flexible. You are really flexible because you basically are already inside of the project you don't even know about, and that's so cool about it. There are some disadvantages, however. So there is a high entry level. Obviously, as mentioned before, you have to actually have some either background in functional engineering. You definitely have to either be already somehow Lisp-oriented engineer, or you have to change the paradigm of thinking by entering the stack. And obviously, there are not that many developers on the market. The ecosystem doesn't have the critical mass yet. And basically, it's not a perfect pick for something very small. But the question for us is like, some may say it's a niche technology. Is it actually a problem? From the experience of our company, from the experience of the projects we were working on and the products we created, no, it's not a problem because of many things. First of all, the technology becomes more and more popular with like, let's say, startups, and startups, it's not a small niche, it's a quite a huge market. Also, there are various, let's say, domains that are actually kind of benefit from Clojure, video streaming, healthcare, fintech, and I can, talk forever. Name even Netflix, that one, which is one of the examples of the huge company using Clojure stack. And but basically, the hiring opportunities are very, like I would say, for the last 3 to 4 years, during COVID era and many other stresses of the today, especially in Ukraine, are actually like, these are opportunities because of many things. First of all, more and more engineers, mature engineers, senior engineers find Clojure and fall in love with it because it's like so easy to build end-to-end products, and engineers definitely love to see their efforts being used by the end users. And obviously there is the possibility to learn and to kind of basically make it a possibility, opportunity for your engineers in your companies to learn Clojure, as Andriy did in his time, and to kind of become an adept of this language and see its opportunity, not forgetting the previous stack the person worked on, and be able to operate in different systems. Over to Andriy, and let me see what we have here in the Q&A.
Yeah, so actually, like, it's kind of related to what Anthony asked. So the hiring opportunities, they're not limited to the Clojure developers itself. So you can also search for Java developers or for JavaScript developers. That kind of creates you a bit bigger market. For those kind of persons, it's easier to switch to Clojure. You just have to like show it to them and convince them. So that's the tricky point, obviously. But that creates you that possibility that from our experience, people who switch from Java, they can master Clojure relatively quick. It's easy for them to, like, they can reuse a lot of existing and well-known libraries there. They just have to adapt to this new functional way of thinking, to all those like recursion that goes along to that Clojure immutability. But that's the other part. So in general, like, it's not that necessary to hire a Clojure developer if you already have a team. So like, when you start from scratch, obviously you need some experts to build all the process, but then it can be like there are options. And other benefit, I would say, that it's a friendly and mature community that Clojure have. So it's relatively small, but at the same time, we love that language so much, and we are so open from everybody who are brave enough to try it and understand its beauty. So like everybody literally trying to help as much as possible. You always have a lot of answers on the Stack Overflow, like from maybe like a smaller amount of people than for other, but they're active. There are some panels that you can collaborate. So they're like Clojure community always want to help. And it's the mature community because it's a niche, it's a bit scary, yeah. So like at least in the mind of like most people, yeah, right now. And people who decided to switch to this technology, like I'm saying switch because there are not so much people who started with it. I think there are just a few of them in general. And they are mature enough, they're usually seniors. So that creates that cost because they usually have a higher background. But like at the end, you have a senior that have a major experience in general, and also senior that master a new great technology. And also he is brave enough to try something unusual and like actually gain a benefit from it. Because if it's something unusual, it doesn't mean it's bad. It just means that it just couldn't get its like popularity as at this point that much as other technologies. They're just, in my opinion, they're just simply easier to enter. And that's the big problem of Clojure. So when you look first time on a Clojure, you just have this a lot of parentheses, kind of a scary code. It's hard to leave, but it's yeah, it changed. Like I spent around like 2 or 3 weeks struggling with it, but then like for me now, like it's way more natural to read that Clojure code than any other like more typical object-oriented code. And this created
Andriy,
this.
sorry to interrupt, but we need to speed up a little bit because
Okay,
we
I will
are
try.
out of time.
Yeah, so this created a solid impression of like Clojure as a technology, of your team as a Clojure team. So it's just maybe some psychological aspect, but it's still there. And the other possibility to reduce this, like the salary aspect that Clojure developers usually want, is train your students. By students, I mean not only the actual students, but the switcher, but we also try to just train the actual students from a higher courses of university. And it went great, actually. So they all were extremely excited. I made like maybe kind of a similar introduction to them, like what is Clojure and how to work with that. And they were excited about this idea. So it works well with the newbies as well. And they are under impression that they can start with something that cool as Clojure, that not everybody want to start it. They're not brave enough to start it, but it was the good decision for them, and they now admit it because we hired a lot of them. And it proved that like it's relatively easy, 3 months for a student to handle the Clojure stack, not the only like the language itself. So it took for them 3 months, but I'd say it was like a good result. They are able to help on a project as a full stack developer, and they are loving that language same as we do. Like the downside of it, it requires supervision, obviously, because it's harder to put them aside and say just, hey, here's some book, learn it. It will be just too hard for newbies to do that, because actually that's a kind of a mature technology that usually comes from like the switchers, or like it doesn't have like that much of welcoming for like the students or people who don't know like that much different technologies and just some basics. But with a proper supervision, it's very easy to guide them because Clojure itself is simple. It's just, it looks scary, but really it's very simple structure, very simple flows. So it's easy to learn, I would say, but hard to master. So you will have obviously then to develop yourself and try to have like more like complex solution, but that will be later. For a general purpose, it's absolutely okay to hire even the students in the way that we tried, and it worked perfectly well.
So answering the question from the Q&A chat, yes, we do conduct the courses in Clojure in the company. Please follow the announcements on the social media, LinkedIn, and etc. For the new announcements. And it's such, I would say, such a high rate of success for the courses, 80% of success, which is really cool. And some of the kind of students, so to say, were actually just the entry level to the software engineering, and some were switchers, but basically that was quite a high rate of success. I guess we are
yeah, I think the key to this success was their excitement, because we give them such a powerful tool that they were able to do great things with, and they were not limited to just some small part of the industry or for application as or their friends or colleagues.
Yep. Yeah, so I guess with that, that would be it of our sharing of our ways to be more agile with Clojure Stack. In case there are some questions and you didn't ask them yet, but you can definitely try the chat again. It should work now. And Q&A section, we would be happy to answer any left. Thank you all. Yeah, I think, Andriy, if you can move to the next slide, here are some of the contact information. So if you are interested in some more details, more knowledge sharing, or any questions related to the courses or the success stories with Clojure Stack, please do not hesitate to contact us. And thank you all for attending. Have a great day and evening. Bye.
Thank you, everybody.